Really good to see you, Paul.
It's great to be here, really
Nice
is.
to have you back in the UK.
It's been too long, much too long.
It was very kind of you to bring the weather with you as well.
If you don't mind, I'm going to leave it.
Yeah, well, I'm glad to see you. Maybe we should kick off just with a question.
Sure.
In the UK, we've got a pretty diverse range of machining environments, especially when it comes to things like milling. You've got little companies doing simple toolroom work, one-off components, never doing two of anything.
Sure.
You've got companies doing batch work, sometimes repeat batch work, all the way up to companies doing more sort of continuous production.
It's very true.
I think their requirements from the work holding are equally diverse.
Yes.
They have different priorities, obviously. So where do you see the Chick range of products kind of fitting into that kind of a diverse range of requirements?
We've got a couple different products, but before I would jump into that, I would mention that actually within each company, they're going to have diverse work. So you have people that are just doing one-off repair work, spare parts, things where they just do one piece at a time. And then other places where they're going to be doing batch work and then potentially have a big order from a client and they're doing high volume parts. So even within a given company, there's that same type of environment.
Absolutely. I've worked in companies that have a machine shop dedicated to certain types of jobs and a tool room that just spends all day making fixturing or repairing tooling or that kind of thing.
Exactly.
So quite right. Yeah.
Exactly. So within Chick, we kind of cover the gamut being one-off manufacturing all the way up to high volume production. In the one-off manufacturing, we have the one-lock product line. It's designed to hold one piece. When we design this product, we focus on the machinist. And we work to make the product so that the part stays close to the machinist. So instead of the part being located in the back of the system and the front jaw moving and closing, we flipped it so that the part stays closest to the machinist, and we can adjust the length by moving our quick slide jaw here.
Right, so the part's actually closer to the operator.
Exactly.
So you can see it better when you've got the doors shut and there's coolant flying around and swarf everywhere.
Right.
You can see it better. Maybe you're not reaching in as much when you're loading.
Exactly.
Okay.
Exactly.
That makes sense.
And then you can also do your inspection without having to crawl into the back of the machine and have coolant dripping on your head. And
go home with swarf in your hair.
Exactly.
Yeah, I've been
exactly.
there.
Yeah. So this whole product line that we designed also so it's quick changeover. So you can, by removing these little screws here, this whole product, the jaws come off very quickly. You can change out from one setup to another setup very, very quickly. You can use hard jaws. It's all designed around trying to make the machinist as efficient as possible and make their life as easy as possible.
Okay.
When you start to have parts that repeat, and you're doing a batch of 1, 2, 3, 5 parts, you still will be in a one-lock realm with these quick change machinable jaws that we have here, which we call bolt-fast machinable jaws.
Right.
But when you get to a batch size of somewhere between 10 and 15 parts, and that's very dependent upon the number of tools that you're running, it makes economical sense to move to a quick lock.
Right.
When you take the step from going from a single station clamping solution to a 2-station clamping solution, typically around 10 to 12 parts is where you'll see the number of tools being used can be amortized over those 2 parts. And suddenly your cycle time is reduced by a significant margin. And so if you're doing batch production work, that's when we look at the quick lock. Okay.
I see.
Okay.
So that's where you're effectively taking all your non-productive time in the cycle and you're sharing that across 2 parts instead of just 1 part. So the cost of that time is then effectively halved per component. People underestimate how much of the cycle can be made up of that unproductive time. Yeah.
It's very true. We typically see somebody going from a 1950s style product to the one lock, they'll see an increase 10, 15%. When you go into this range here, and you're doing a batch of 10 or more parts, you're going to see a 30% at a minimum savings on that.
Right.
Cycle time drops by at least 30%.
Which means more profit at the end of the day.
Absolutely. More parts come off. It also means your machinist is more productive too. So that's one of the things that will happen is you'll see the machinist will have the ability to set up and run these parts. The machine will run for a longer period of time unmanned because it's doing 2 parts, or if you have 2 of them, 4 parts. So now the machine's running for a longer period of time, so your machinist can be getting the next job ready to go. And there's less downtime due to changeover time, etc. Again, it's pretty impactful.
The other thing I sort of see from this side, from the quick lock side, is more efficient tool paths. So you're using the same tool.
That's true.
To do 2 components or however many components you've got in it, whether that's 2, 4, and then you're using the same tool on the path. So you're not going home to tool change. You're not losing that 6 seconds. The machine will say it's got a half a second or a second tool change, but your tool change is actually from when the spindle stops cutting metal, returns home, indexes the tool, and gets back to the job and starts cutting. Average, that's 6 seconds. So if you're spreading that cost across 2 components as well, you're actually saving again.
Absolutely.
Yeah, that's quite true. I mean, with modern tooling, sometimes your in-cut time can be quite a small amount of time.
Yeah.
I mean, if you think of a carbide drill, it can drill a hole in steel in 3 seconds. So
Yeah.
you could have a 9-second cycle,
Yes.
of which 60% is non-productive time.
Absolutely.
So you spread that over 2 parts. You just put a second component next to the first
Yeah.
one. You've added another 3 seconds to that cycle, but you've
Exactly.
doubled your output. So, I like it when people look at the numbers, because often they don't lie. It's easy, to look at something and have some anecdotal sort of subjective idea of whether it's a good idea or not, or productive or
Right.
not. But when you look at the real numbers, they tell the real story.
It's true.
Yeah, very interesting.
Yeah, it's more as well getting people to look at, because they manage the way that they're doing it. They've always done it like that, and
Yeah.
they manage. Is getting them to look at making that little bit of an outlay to get a system in that's going to actually improve things. And yes, they've got to spend some money, but how quickly does it repay? And then once it's repaid, how much extra money do they make?
Right.
And it's exponential. Like, it just grows, because once they see it works on one product line or for one specific kind of job, you think, oh, okay, how else can we utilize it? And then that's where you start seeing improvements going factory wide then.
Exactly. Yeah.
When we're looking at our product and designing products, we look at it to pay off in less than a year.
Right.
So our design criteria is around under 12 months. A typical return for a quick lock compared to an old station vise, if you went and compared that, you would see this in about 12 weeks. Typically,
Right.
somebody will pay for the product in less than 12 weeks.
Right. But just to clarify, though, we're talking about at a certain level of volume of parts. If you're
Yes.
doing one-offs, that's not the job.
Right. This is where you get.
That's
the
where you
return.
look at. And that's something I just want to touch on as well, because that whole side of machining, your one-offs, your tool room type work, you don't often see a lot of new technology in that area, because people are just accepting of a massive amount of setup for a small amount of machining,
Right.
and a fairly inefficient production process. That just seems to be what everybody believes one-offs and tool room type work is like.
Right.
But that brings a new dimension to that. It's a more modern approach
Yes.
to work holding in those sorts of environments.
Yeah, very much so. Yeah, the keys here. If you look at this base, you'll see there's no chips, no nooks and crannies here.
Right. So you've got
Typically-
clean surfaces.
Typically, you'll have a big trough there that the slide assemblies you open and close the jaws fully. We've eliminated that with the quick slide mechanism we have. So this is a much, much cleaner environment, faster part changeover. With our bolt fast jaw changing system here, what you end up with is the ability to very quickly take the jaw off and relocate it within microns or tenths of an inch, 10,000ths of an inch.
Right. As opposed to where in a traditional vise you normally have bolts,
Yeah.
bolt-on jaws, which
Exactly.
where you have to get into the front face of the jaw, which isn't
Exactly.
always easy to do when you, especially if you're reusing a set of jaws you've machined for a job.
Yeah.
It's very awkward to try and get your whatever tool you need in
Right.
there and get the part in place to align the jaws, because they don't line up. They don't automatically align correctly, do they? So that will eliminate quite a lot of time.
And the other thing that's worth remembering when you're changing jaws on the old style vise is, if you're doing a really small component, you've got to wind it all the way out to be able to get your Allen key in to even look at changing those jaws.
Right. Yeah.
Did you know how many turns it takes to go on a 1950 style vise, the one that everybody has in their shop somewhere? If I want to go from a fully open system to a closed system, how many times do I have to turn that handle to make that happen?
I don't know, 10 or 15.
Three days worth?
I don't know.
Genuinely.
Genuinely.
No idea.
70.
70.
70 turns to
70
go from
turns.
fully open to fully closed.
Wow.
It's crazy.
is,
Absolutely crazy. It's
yeah.
2 to 3 minutes to do that. And obviously now we've got something that's quick slide and get some customer there what they need faster.
Within a few seconds, right?
Yeah.
Now, you mentioned the bolt fast jaw system. And we can see we've got a set of machinable jaws on there. I mean, I like machinable jaws because there's so much you can do with a machinable jaw. A lot of people think of them as just for the awkward shapes, the difficult things, but you know, you can just mount a set of machinable jaws in a one lock and just skim them square to your x-axis of your machine, and you wouldn't even need to clock your work holding up. So, you know, there's lots of ways they can be used. You can use them, for instance, to have more than one operation at a time. Like, for instance, mounting a workpiece, doing up one, turning it over in the same set of jaws. So you can combine operations. But what other kind of jaws are there available for the one lock?
We have hard jaws, just regular plain jaws that you would use if you wanted to have parallels.
Right.
We have step jaws.
Step jaws,
and we also have a jaw here, which is called a spacer jaw. So it's got these two holes here.
Yeah.
And you slide it in place that you can bolt the old-fashioned jaws through to.
Right.
So if you had, sorry, I was just about to ask, I think you were about to answer.
Go ahead.
I do apologise. So if you had lots of sets of old jaws that you didn't want to get rid of, you could still use them.
Exactly.
But to be fair, though, if you did that, you'd lose all the benefit of the bolt fast system. So you wouldn't have your quick change. So that's not something you'd do unless you really needed to. But the option is there if you have to.
Yeah.
Well, that's great. Covers all the bases.
The key in this type of environment, one-off, is the machinist is typically very skilled. They're knowledgeable because they're being given a program to write and a part that they've never seen before. And so that person is going to need tools and have the ability to be very versatile in their thought process. So when we've designed this, we've designed that with that in mind. So there's a lot of versatility built into the system. It looks very simple, very easy, but there's a lot that went behind the design of this product for us.
Right.
So I put 3 of those into my previous employer. Because obviously I was in a machine shop before I started this role. And what it's done is it's allowed them to increase all of their depth of cut, speeds and feeds by 40%.
By which?
40%.
Wow, that's incredible.
So they can now attack much harder knowing that they've got a solid clamping where it's not splaying or lifting, and they are now running. The article's actually on our website, where we went in and interviewed about how they found working with the Chick, and they're like, it's night and day to what they had in the shop before they went onto the Chick Workholding.
Fantastic.
So the one thing that we do get asked a lot is the base is now made of aluminum.
When vices were first designed, they were going onto a table that was this thick, this deep, and they overhung. So that's why they're made from cast iron. Nowadays, what happens is that they are the clamping systems. The tables are much bigger, and the clamping system is resting on that bigger station.
Continuously supported.
Exactly. And so what ends up happening then, when you have the base, as you tighten it down, it wants to meld to the machine. It wants to bow. We're holding it in place, the clamps, and so everything becomes a common piece, like you said, like part of the table. And so the vibrations then can transfer right through the system into the table itself. And so it is a much, much more optimal plan to use the high-strength aluminum. The other benefit that comes with it is it doesn't weigh as much, so it doesn't cause as much wear on your machining center.
Right.
And also, on the weight thing, especially here, I don't know what it's like in the States.
Yeah.
We've got the safe one-man lift of 25 kilos. Well, the steel vices tend now to be a lot more than 25 kilos, whereas this is falling in the 1540 is, I think it's 21. No, it's 18.7. Sorry, the 1550 is 21.4.
Yeah.
So, you know, both of them, even the bigger version of that, is well within the safe one-man lift. So from a health and safety point of view, even you've got bases covered.
So just out of curiosity, what type of aluminium is it?
It's an aircraft grade aluminum.
Okay.
Let me try again. It's an aircraft grade aluminium.
Right, so we've talked quite a bit here about the one lock and its purpose in the tool room. Would you mind if we move across to System 5 and we'll have a look at sort of where this fits in the manufacturing world?
Yeah.
Okay, so we have the demo product set in front of us here.
Sure.
And the jaws are machined in an op1, op2 sort of fashion.
Correct.
Is that completely necessary in order to use the system effectively?
No, you can make a set of jaws to hold just operation 1 and just operation 2. The advantages here are that, like you said here, we've got the op1 part sitting closest to us and the op2 finished part in the back jaw. By doing that, that gives me the ability to produce one at a time. Every cycle after the first cycle, the second cycle and beyond, will produce a finished part. Okay? And the smart part of that is that I get a chance to inspect a completed part. I don't run 50 op1s or 25 op1s and then go to the op2 and then realize my op1s are no good.
Right.
So relative to the op2. So now I run op1, op2 together. I get a finished part off, I inspect it, I make sure everything's good before I start to roll them through. So that's an advantage there. If I'm going to be doing a higher volume of production, I may want to run 2 op1s and 2 op2s. The reason for that is then I can amortize the tool change time over 2 parts and reduce the cycle. Plus, I only run the op1 tools on the op1 parts when I'm running them, and on op2 only parts, tools will be running on op2 only parts.
So that would be your most efficient way
Yes, of running these parts.
of running a dual station work holding, duplicating 2 components, identical ones with identical tool changes, so
Correct.
that all of your non-productive costs are then spread over both parts exactly evenly.
Exactly right. Yeah, and so what ends up happening is you'll see a couple minutes per part savings by doing that.
Yeah. Okay.
It's pretty amazing how the small little change of going from 1 part to 2 parts can have such a tremendous impact on throughput. We've seen literally gains of an hour, 2 hours on a shift just by going to running 2 parts instead of 1.
So that's the way these jaws are set up. But I believe the movable jaws are reversible.
They are reversible.
So you could conceivably turn them around and use them for something else.
Exactly. Yeah.
Just replace the center jaw with a new center jaw, and then those same 2 movable jaws could then be completely different component.
Exactly. And what you could do is you can have a step jaw scenario where you have a part and you want to go to a shorter jaw, you just flip the movable jaw around and it holds closer.
Right. Okay. So you don't have to have a set of jaws dedicated to one job. As you can see here, does 2 different operations. Could even do more than that.
Correct.
With one set of jaws. But if you want to, you can dedicate
Absolutely.
a set of jaws to a job.
Yeah, absolutely.
Take them off, put them on the shelf or in a pigeonhole or something.
Absolutely.
Whenever that job comes up, jaws back on, off you go.
Perfect.
Well, I mean, to me, it's like the base is like a 0-point system. If that's always on, you can have it set up however you want and strip it and reset it for a different job
Absolutely.
within seconds.
Yes.
It's amazing.
I mean, there's a huge versatility advantage in that,
Right.
I feel.
So yeah, I mean, when you're looking at this as a system, and you've got one customer wanting this job and one customer wanting that job. With conventional work holding, you'd be looking at hours of setup, lots of effort. Whereas with this, you're coming along, you've already got the setup for both jobs.
Sure.
So your minutes to set up, do a run for them, strip it down, put the setup on for
Sure.
customer B, get that done, and you're getting that throughput. Both customers are happy.
Right.
Your operator's happy because he's not having to work hard resetting stuff and setting tools.
Sure.
And keeping the machinists happy is a big part of retaining staff now as well. If their life is more comfortable for them.
Sure.
I get what, yeah. It's like being, you can become super flexible.
Exactly,
And you can easily accommodate. I mean, one of the things, in a way, I suppose, you're reducing your lowest economical batch quantity, really, aren't you?
Wow, look at you
Because-
go with those big words, and you're absolutely right.
Well, because effectively, your lowest economical batch quantity becomes 1 part. Once you've set that up and you've used it, I mean, we're talking about repeat work now,
Sure.
aren't we? So once you've set that up and you've used it, the amount of setup time needed to produce 1 component becomes so small that it's now feasible. If your customer has a massive demand for a single part, it's feasible to do it
Right.
without it costing more than it would have
Right.
if you were doing a batch of 100 parts, isn't it?
Yeah, but I'll just tell you a story. You were talking about economical batch quantities. What ended up happening with at the company that was before Chick, where we started as a contract machine shop, and we had a customer that was a very large customer of ours that wanted a job set up and operational. We spent hours setting this job up, as you did back then, to get everything tweaked in. And this is before Chick Workholding existed, okay? So we set the dedicated fixture up. We did all the things we did. We got it just so. And the customer called up and says, no, we don't want those. Take that down and set up this other one. And so we said, but we just, take it down, set up the other one. So the customer told the salesperson told the machinist broke it down and set the other job up. My father, who owned the company, came walking by and said, what happened with the setup that was on here? The machinist said, the customer said they don't want this part, they want to run part B. So my dad said, well, so we broke it down and we're running part B. My father said to the salesperson, we just spent hours setting this up. Who's going to pay for that? And the salesperson said, well, they said they want this. My father said, well, tell them to pay for the difference. And the salesperson said, they're not going to give us the work if we keep charging for this. Father said, look, they're asking us to do this, we'll change it over. And we lost that order because we were going to charge them for the changeover. And suddenly we had to think of a better idea and a better way of doing quick change. And that's kind of where the concept of this quick change machinable jaws and everything came from.
Especially in a tool room environment, like the amount of times that's happened to me. You literally just finished setting up, you get all your tools in, you get your work holding set up, you've probed your datums, you're about to start proving your program through, and they come along and go, no, take it off.
Yeah.
And you're like, I've just wasted an hour and a half.
Yeah.
But now, you'd be like, yeah, okay.
Yeah.
Snap your jaws off.
You go right back
and go back to any other job you've already done.
I can't imagine anyone watching this hasn't been in that situation. Because I know I've been in that situation too. Everyone has.
Well, the part that I'm a little uncomfortable with talking about, the part that my father said, let's go back and charge them for that setup. And truth be told us, we did, and we lost that order. They came back eventually, but that time, we took our engineering team and designed the concept you see here with the quick change machinable jaws. And so now we can be much more versatile, much more responsive to our customers.
So I can't help but notice as well, and this is one of the things that I'm a massive fan of with System 5, but it's not just jaws for work holding that's available to you here. We've got the face plates.
Sure.
Would you better talk to us a little bit about sort of uses of that, how that came to be, what the thought process was?
Yeah, that's a great point. So the system here, as you see it, this is a 100 millimeter wide system. Those jaws come off. You can put 150 millimeter wide jaws on, and you can also go to 150 millimeter wide jaws that are a little bit taller. So you can go to a standard, wide, tall, and oversized, which is both wide and tall. Those jaws come off, and then you can go to single station. So this not only can work in a dual station mode, it can also do a single station mode. So instead of holding the two smaller parts, you can hold one massive part across it.
Okay.
Sorry, so in that mode, do you have then one fixed jaw and one moving jaw, rather than in this where you've got a fixed jaw in the center and you've got your two moving jaws?
Great.
Single station mode, one fixed jaw, one moving jaw.
Exactly.
Clamping larger workpieces, right.
But maintaining the squeeze clamping concepts that we have. So one of the things you have in a 1950 style vise, you have a fixed jaw, you have a movable jaw, and as you drive your part into the fixed jaw, suddenly your fixed jaw is not fixed anymore. It starts to flex, okay? What we've designed into here is a squeeze clamping principle, where you have movable jaws on both sides. The fixed jaw is fixed in the middle, and you squeeze. The harder and harder I squeeze, doesn't move this jaw at all. Whereas if I do this, it starts to actually hurt and yields, okay? When we take this and go to a single station mode, we still have the same squeeze clamping that's occurring, but now just around the part.
Right.
And then you take those jaws off, and now you can go to a faceplate. And the faceplate is one big fixture plate that will locate on there and again use the squeeze clamping to hold itself in place. So now I can take and convert a clamping system, which is just designed for holding with jaws. It now can convert to a fixture quick change pallet system, if you will, a manual quick change pallet system.
Yeah, so you're not only giving like a 0 point fixture, basically, but now if you're doing smaller components, we talked earlier about spreading your costs across two components. If I can fit 15 or 20 components onto my dedicated fixture, I'm now spreading that tool change cost across 15 components or 20 components. I think the savings there, like,
it's huge.
It's massive, and it's one of the things that I love is the faceplate and fixture element of the System 5. It's one of my favorite things about the system, to be honest.
We have had instances where we designed and helped someone to manufacture parts that are really turned parts you would normally get off a lathe, onto a faceplate fixturing setup, and been more productive and more cost effective on a mill doing turning than on a lathe doing turning. It was absolutely incredible to see that.
I suppose then you could make duplicate faceplates
Yes.
and load them outside of the cycle.
Yeah, exactly. That's
So you've got something like a pallet changer, don't you? But it's manual, but you get all that benefit of your loading outside of your cycle. So you've got all of your non-productive time spread over a large number of parts, plus all of your loading time outside of the cycle. You're going to see a very big productivity improvement just with a change of work holding. So without changing any of your tooling or your process or your cutting data, all of that's exactly the same.
Right.
Just with the change of work holding.
That's very true.
See a very big change in your productivity.
Yeah, it's very, very true. Yeah, and that's what very well stated, is that the changeover time is, say 30 seconds, and you have 10 parts. It's 3 seconds per part. So literally it's that fast. And then all the part change time that happens outside the machine is happening whilst the machine's running. So I have uptime, and I've got freedom, what we call walk away time, where I can walk away from the machine whilst it's in cycle.
And then do your inspection, make sure that you don't skimp on your inspections.
Absolutely.
And keep your quality up to 100%.
Yeah, fantastic. Yep, that's exactly right.